Hi, and welcome to this video on transformations, reflections to y. Okay, so in this video, we're going to talk about reflections. In the last video, we talked about reflections when they apply to x, but today we're going to talk about reflections when they apply to y. Okay, so how do we know if a reflection applies to y? Well, in this case, it's usually outside of some type of parentheses, okay? Or it's in front of the whole function. So for instance, if we look at y is equal to negative x squared, when we were applying it to x, it was y is equal to negative x and then squared. But the fact that the negative is not inside the brackets here, it's outside the brackets, it's being applied to x after we square it, whereas here it was being applied to x before we square it. Okay, so that makes the biggest difference. Okay, so and in this case also, y, when it was being applied to x, it was the absolute value of negative x, but in this case, we can see that the negative is being applied after we take the absolute value. So when it's being applied to y, it's being applied after we do whatever it is that we intended to do to the function. Okay, so the function below, y equals negative x squared, the parent function is actually y equals x squared. Okay, so what's been changed? It may look like the parent function, but it's not, because this negative here has been applied. Okay, so let's talk about what that will do to our function. But first, let's graph the parent function. Okay, so I'm going to graph the parent function maybe in blue. Okay, so our parent function for y equals x squared, we know our values would be the square, so every x would be squared in order to create y. So 1 would be 1, and 2 would be 1, 2, 3, 4. 3 would be 9, and the same thing on the other side. So 1 would be 1, negative 1 would be 1, negative 2 would be 4, and negative 3 would be positive 9. Okay, and so we get our basic parent function parabola here. Okay, so I'll label that as the parent function. Y is equal to x squared. Okay, so how does that affect it? Well, what happens is anytime we're applying anything to y, it is as it is. So if it says that we're going to take the negative and apply it to y, well, what's going to happen is all of our y values that are positive up here, so in this part of the, in the quadrant 1 and quadrant 2, now they're going to go to quadrant 3 and quadrant 4. So when we have x is a value of 1, then y is a value of 1. Now y is going to be a value of negative 1. So we're going to basically negate all our y values. Whereas we have the point 2, 4, now it's going to be 2, negative 4. Okay, where we have the point 3, 9, now it's going to be 3, negative 9. And the same thing on the other side. Negative 1, 1 is now going to be negative 1, negative 1. Negative 2, 4 is now going to be negative 2, negative 4. And then the same thing for 3. Okay, so what happens is all of our y values become negated, or the opposite of what they were before, and so it causes a reflection, a mirror image below the x-axis. So remember that when we apply a reflection to y, it actually makes the function turn down, up or down. So basically whatever our y values were before, they now become the opposite. So if they were positive, they become negative. If they were negative, now they become positive. Okay? All right, so let's look at that again. Let's see how it applies to the absolute value function. So the parent function here would be y is equal to the absolute value of x. So let's graph that. We know that that's a one-to-one relationship on the positive side, as well as on the negative side. Okay, so we have this function right here. This is the parent function. Y is equal to the absolute value of x. Well, how is that going to change our function? Well, let's go in another color and change that function. Okay, so whatever y was, now it's going to become the opposite. So if y is 0, well, obviously it's going to stay 0. So that's still at the origin. But 1 is going to become negative 1. 2 is going to become negative 2. 3 is going to become negative 3, and so on. Okay, same thing on the other side. Negative 1, negative 1. 2 will become negative 2. If I have 4, that will become negative 4. So 1, 2, 3, 4. And actually this one should have been going through 4. So just to make sure that our functions are lining up correctly. There it goes. Okay, so what we get is a function that is the opposite and reflected down, or reflected in the opposite vertical direction of where it was before. Okay? All right, let's try another one. Let's try a couple more. Let's see what happens to the exponential function. So if I have negative 2 to the x, the parent function is y is equal to 2 to the power of x, and we all know what 2 to the power of x looks like, or we at least should by now. We've been studying these types of functions for quite a while. Okay, so we know that if we take 2 and raise it to the negative 2 power, it's going to be 1/4, and then raise it to the negative 1 power, it'll be half, to the 0, 1, to the 1, 2, and to the 2, 4. Okay, so we get our exponential function with a base of 2, looking just like it is, right? If we raise it to a power of 3, that becomes 8. So it should be passing through those points. So just to get a bit more accurate of a graph. And so the same thing happens. Whereas we looked in the last video, and if we had an exponential, right, it would be reflected across the y-axis. In this case, it's going to be reflected over the x-axis because we're negating our y values, not our x values. So if if y was 1, now it's going to be negative 1. Where y was 4, it's now going to be negative 4. Okay, where y was 8, it's now going to be negative 8. And where it was 1/2, it's now going to be negative 1/2. And where it was 1/4, it's now going to be negative 1/4. So what we get, this actually completely changes our range. Our range will be the opposite of what it was before. Okay, when we look at this function. So before, our range would have been y is greater than 0. Now, obviously, it's y is everything less than 0. Okay, so all of our y values were negated. Okay, let's try one more. Let's try the linear and see how that one works. Okay, so the linear is a special case because whenever we negate a linear or add a number to a linear, whenever we transform a linear function, it actually always ends up being applied to the y value. So this one is a special case because a linear is just a line. Okay, so let's graph our linear parent function. Y is equal to x. Well, we know that it's a one-to-one relationship, right, in both directions. Okay, so we graph our linear parent function. Pf y is equal to x, and that's what it looks like. So now we negate all of our y values. So the y values that were positive are now going to become negative. Okay, so we get a function that looks like this. And the y values that were negative will actually now become positive. So remember that I said that whenever you negate your y values, they're going to become opposite of what they were. Okay, so in this case, it flips our linear function around so that now it's in the opposite direction. Okay, so now we have a negative slope. So this one has a slope y equals x. This one has a slope y equals negative x. Okay, so we negate all of our y values, and it basically makes our linear function rotate 180 degrees, so it becomes opposite. Okay, if you have any questions on applying this, hopefully these videos will help you. And then also just get lots of practice. So the next time we'll be actually putting all this together. So you've learned so far about transformations in the sense of dilations and how multiplying the function by a number, multiplying x by a number or y by a number will affect the function. Then you looked at reflections to x, how putting a negative in front of x will change what the graph looks like horizontally. And so now we've looked at y, and we can see that putting a value, applying a negative to our y values will actually change the direction of the function as well, but it's going to change it vertically. So if it was increasing, now it's going to be decreasing. If it was decreasing, now it's going to be increasing. So it basically mirrors itself across the x-axis. Okay, so I hope this video has helped. Look at it as many times as you want. Go back and pause as needed, and make sure you get lots and lots of practice with these, because the more practice, the better you get at it. All right, thank you, and see you in the next video.